Hello everyone, welcome to Simpl-Techie, a channel where I explain programming concepts in simple terms. The topic we are exploring today is layered architecture pattern. We can use this pattern whenever we are writing code for a backend application, a desktop application, or a mobile application. This pattern is especially relevant when working with object-oriented programming languages like C# or Java. I want to credit this book, Domain-Driven Design, as the content of this video is based on this book. Let's get started. Let us begin by understanding what is the layered architecture pattern. It's a design pattern to manage code complexity. And it achieves that by defining layers with separate responsibilities to organize the code. Let's unpack that a bit more. The layered architecture pattern advocates for 4 layers in any code base. The topmost layer is the presentation layer, followed by application layer, followed by domain layer, and finally the infrastructure layer. Let us understand the purpose of each layer. The presentation layer is responsible for showing information to the user and interpreting user commands. The application layer orchestrates between the domain layer and the infrastructure layer for business logic and persistence. It also acts as a bridge between the presentation layer and other layers. The domain layer is responsible for all business logic of the domain. The term domain here refers to the business domain for which you are writing the code. For example, e-commerce, healthcare, or finance. The infrastructure layer provides generic capabilities to support the higher layers. For example, persistence or sending notification. This distinction will be more clear as we see some more examples in later parts of the video. Now, there are some rules governing communication between these layers. Let us understand them. Rule number 1. Classes can depend on classes in the same layer or lower layers. However, lower layers should have no knowledge of or reference to classes in higher layers. That's rule number 1. Rule number 2. Any communication from lower layer to higher layer must happen through callbacks or the observer pattern. The only exception to that is when the lower layer is responding to a direct call from the higher layer. The reason for this is to reduce coupling between the layers. Rule number 3. Domain layers should not interact directly with persistence logic in the infrastructure layer. The reason for this is to keep the domain layer separate from any persistence logic. Now that we understand the layered architecture pattern and the responsibility of each layer a bit more, let us put that in practice. Consider a scenario where we need to transfer $100 between 2 bank accounts. Now, how would we separate the code for this scenario between the different layers? For this scenario, we may have a transfer controller class in the presentation layer. We may have a fund transfer service class in the application layer. We may have a fund transfer domain service class in the domain layer. We would have the 2 account objects, account 1 and account 2, between which the fund transfer needs to happen. And we would have the account repository class and transaction manager class in the infrastructure layer. Now, when a fund transfer request is received by the controller with the given account numbers, it transfers that request to the fund transfer service class. Now, as we are dealing with 2 accounts where the debit and credit needs to happen, which could potentially be 2 separate database operations, which need to be atomic in the sense that either the debit and credit should succeed together or fail together. We would need a transaction. to handle this. So the fund transfer service will use transaction manager class to begin a transaction. Now you may ask, why not put begin transaction in the fund transfer domain service class? Now that would violate the rule we just discussed, where we said domain layer should not have any reference to persistence logic. So that's why persistence logic is handled in the application layer class. Once the fund transfer service has begun the transaction, it needs to fetch the account objects for the given account numbers, for which it needs to call the account repository class and get the accounts. Once the fund transfer service has the accounts, it can then delegate to the fund transfer domain service class to perform the transfer. The fund transfer domain service class can instruct the account object to perform a debit of $100. The account object can then check its balance to see if it has sufficient balance before performing the debit. Subsequently, the fund transfer service can instruct the account to class object to perform a credit of $100. At that time, the account to object can check whether it is inactive status, for example. When all this succeeds, the fund transfer service needs to save both account 1 and account 2 using the account repository class. When both those operations succeed, the fund transfer service needs to commit the transaction using the transaction manager class. So that is how we would divide the fund transfer functionality between the different layers in the code. Now that we have a better understanding of layered architecture pattern, let's do an exercise. Building on the previous example of money transfer between bank accounts, let's identify where each of these scenarios belong. Sending SMS of credit or debit. Which layer does this functionality belong? In the application layer. The concept of sending an SMS or email has no place in the domain layer, because the domain layer is only concerned with debiting and crediting of the accounts. Therefore, this belongs in the application layer. Utility for sending SMS of debit or credit belongs in the infrastructure layer. Checking account balance before withdrawal belongs in the domain layer. The account object of the domain layer should be responsible for validating balance before withdrawal. Validating user inputted account number belongs in the presentation layer, as this is concerned with the user input. Checking account active status belongs in the domain layer. Exporting account transactions to an Excel file. This is an interesting one. Belongs in the application layer. So while the account object of the domain layer may hold the transactions, the domain layer itself does not have any conception of a file format like an Excel or a CSV. Therefore, this belongs in the application layer. Getting last transaction of the account belongs in the domain layer. Utility for making network calls belongs in the infrastructure layer. To summarize, in this video, we discussed what is the layered architecture pattern and how to use it to manage code complexity. As next steps, next time when you are coding, think about which layer should the code belong to as per the responsibilities of presentation, application, domain, and infrastructure layers. With that, we have reached the end. I hope this video was simple and useful. If you have any questions, leave a comment and I will respond. I will see you soon with the next video. Thank you for watching.